Okay. Hello everyone, I am Shreya representing Team 6 and my other team members are Krishika, Rafi and Shikha. And our topic for the final project is NBA Game Analytics and this is the content for our today's presentation. Our objective is to analyze NBA dataset and to track player performance and game statistics. And moving forward, this is our design and architecture where we are reading data from Kaggle and then through Azure Function application, we are taking the data from Kaggle to Azure Blob Storage. And after that, we have our ETL layer where we are processing our data in Azure Data Factory and storing our data in Azure SQL database. After that, we are visualizing a data set in Power BI, and we have used Python Streamlit API, Streamlit library for the UI. And yeah, that's it. And this is our ER relational diagram. And moving forward, player, team, and game, we have used these dimension for graph set. Player plays for team and team plays in game. Next. And our implementation process is like we have raw data where we are storing our CSV files in Azure Blob Storage. In ETL, we are using Azure Data Factory to process it. And in the foundation data layer, we have all our data tables in Azure database. And here you can see this is the Azure Blob Storage where we have more than 15 CSV files stored. And this is the code which we used to get all the data in Azure Blob Storage. And so first we wrote this code on our local database and use Azure CLI to deploy this code on Azure Data Factory portal. And we also utilized Kaggle API to get the data from Kaggle to the blob storage. And next, this is the pipeline. You can see first, we also have used a trigger to our function. So this trigger hits our function and whenever the function runs, it will take all the data on the CSV files from Kaggle API and store it to the Azure Blob Storage. Next. And these are the steps or commands we use to deploy our Azure data function from local system to the Azure portal. And moving forward, Rafi will be discussing on ETL layer and design.
Yeah, thank you, Shreya. And as our entire raw files are already in blob from the Shreya's implementation of Azure function, we are building a ETL to move from blob storage to the SQL database, Azure SQL database. For this ETL layer, we have built it data pipeline in the Azure Data Factory. Here we preferred using the sequential because we kind of took a trade-off between the cost and time, and running them parallelly actually cost a lot because of the heavy load at a single point of time. And running very fast pipeline is not an option for us because ours is a batch job which runs once a day. And we have two triggers. We might use one is event based trigger, one is a schedule based trigger. Schedule based trigger runs once every day at 12 a.m. UTC, and event based trigger is some which checks the container whenever a new file comes in. It triggers and loads the data into the database. And let me show one copy activity and data flow that is in the data pipeline that we have. Here is a simple example for the official data table and player dimension table. Here we did a simple transformation like casting the column into the appropriate data type and concatenating the first name and last name into the full name and deriving some of the tables, like simple transformations that we do in a normal transformation ETL. And this is a foundation layer where you can see we have all three types of the data. One is relational data, document data, and the graph data. And here is a graph data foundation layer where you can see we have player dimension as a node, team as a node, and game dimension as a node. And we have the edge tables as place for and place in. Place in as an extra attribute that says whether the team is a home team or the away team. And here we have stored procedures written, which dynamically inserts the edges into these graphs. And these stored procedures also being triggered in those Azure Data Factory whenever the new data refreshes. And here is a sample graph and document queries after the graph tables and nodes are loaded, where you can see a team of loss and yeah. Uh, moving forward to Shrika.
Yeah.
Like considering the time
Sorry.
spent,
Yeah.
we are skipping out.
Thank you, Rafi. I'm just going to switch right into the UI. Like Shreya mentioned, one important part of our uh, components in our project and architecture is our UI. Is my UI screen visible?
Yes.
Yes.
Okay, thanks. So we have provided multiple options for the users. So the idea behind creating a UI is because in most organizations and organization architectures, you don't want to give the business users the entire access to your data set. You don't want them to directly query your data layer because they could update the data, they could delete the data. So here what we're providing them with is an option to, if they want an extract of the data, they could just choose which table they want and then download the CSV file here. It downloads to their local system. Then we have another option where, let's say, a person wants to specifically query something. Let's say they can use this query to basically only select commands they can run. They cannot run anything that could mutate the data. So this again gives the person an option to kind of explore the data without actually giving them credentials to our SQL database. Another option we have here is, like Rafi mentioned, we have a trigger based on storage activities on our bucket. So if there is a CSV file uploaded to our bucket, our data factory will pick that up and will run it through the pipeline and update your SQL database. So just like Shreya mentioned in the Azure function, so our Kaggle dataset is changing daily. It's built out of the actual NDA API and it's available on Kaggle. So every day we run our Azure function, picks up the latest dataset, and that runs through the schedule trigger on Data Factory. But let's say the business user wants to update some small data in one small CSV, they can just browse here and upload the file. Due to lack of time, I really cannot show that. And then the file will automatically get picked up by the bucket trigger and then run through and through. So this is the option we've given in terms of CS in our UI. And our entire project is entirely on cloud. It's entirely live. No human intervention is required for any part of this. Over to Krishika really quickly. Sorry.
No worries. Thank you, Shika, for great explanation on that. Hi, everyone. My name is Krishika, and I'll be taking you guys through the visualization piece. Here we are seeing through the application, the first visualization, which is NBA team player statistics. Once we, so here we can filter by state, head coach or team name, and we can actually see how many team players are there. So for example, here Shika is showing filter by Massachusetts state, and the team is Boston. Their division rank is first. And if we click on player name, then we see the now sum of wins, sum of losses, where they are from. And if you can unfilter everything, Shika, again. Thank you. Yeah, just this as well, team name as well. Yeah, thank you. If you can go to Florida, by state, filter by state, Florida. Yeah, so here by the state, because we have multiple teams here. So yeah, if you click on Miami Heat, that's the team name. Yeah, so we have, so we have no statistics or no other data from this team. So then we can click on Orlando Magic. Okay, so yeah, for this particular team, we have a head coach Azam Jamahi and sum of wins, sum of losses. So yeah, through this visualization, we can see a very deep statistics about player and team. This is again done on a graph data. Moving on to the next visualization, which is understanding more about the player physical performance. Here we can see metrics related to average height, weight, wingspan, standing, leap, etc., etc. So first, so as Shika has already, Shika, can you go back?
Short on time, so we'll just get to
okay.
as well.
Yeah, sure. So yeah, so this is another interesting visualization that we have. This is telling for the, and you can see that it is 2018 season. For that season, we have all these hierarchies of the team that may have played against each other or might have taken part in this whole tournament. So yes, starting with Phoenix, then they like whoever won, then the how it is traversing between the teams. And if you can click on plus one more time, Shika, then we have more traversing and more hierarchies showing up here. So yeah, in all, this is our visualization. Over to you, Rafi, for any questions and answers that we may have from the
Yes,
team.
I'm so sorry
Thank
we
you.
had to cut that short because
No worries.
we'll take any questions that you might have.
So I just have one question.
Yeah.
As you mentioned that you have deployed this on cloud, so like
Uh-huh.
on which service, on which platform have you deployed this?
Which
Azure.
part of it, the UI or the data
UI
platform?
part, yeah.
The UI
UI
is
part.
built using something called a Python Streamlit library. So Streamlit provides its own free cloud where you can host a Python code. As long as your code is in GitHub, it just hosts itself. So you just need to set up the hosting settings. We did not, we could have gone with Azure. Azure supports a VM and you can host that there as well. The reason being, since we have a pretty heavy data pipeline as well as, the blob storage, and we have a few triggers running very regularly and frequently, we are using our compute quite fast. So we did not want to deploy one more service on Azure and incur the extra costs.
All right, thank you.